Hello guys, in this video I am going to be going through the 2023 Mechanics Paper Level 2 NCEA, so let's get started. Question 1, softball match. So this is a diagram here, and the question is, a stationary player accelerates from home plate to first base. So there to there, and the player takes 6.61 seconds, and arrives moving at 5.45 meters per second. And we have to show that that's the acceleration. So as you can see, I've already got my formula down. And while I could use A equals V over T, I don't think they want us to use that because this is level 2 and they usually want us to use a kinematic equation with this. So let's go ahead and put our numbers in. So VF is 5.45 because that's the final speed. VI is 0 because he starts from stationary. It's stationary, so it starts from rest. Plus AT. So A is what we're trying to figure out. And our time is 6.61, which is given. And then we just solve it with this. So we do 5.45 over 6.61, and if you do that on your calculator, you will indeed get 0.825 meters per second. And that is to 3 significant figures. Okay, let's go to the next question. Calculate the maximum displacement between the home plate and the first base. So this is basically asking us to use another kinematic equation to get the displacement. So displacement is basically like another way of saying distance, but like it's the direct distance, so it would be from here to here, like in a straight line, instead of like a squiggly line, or like you might have to go around in real life or something. So that's just like the direct distance. If you were to draw a straight line, then that's a displacement. Okay, so let's answer this. The maximum displacement. So we have VI, we have T, and we have A. So I would take this equation here. So D equals VIT plus half AT squared. Okay, and then underneath that, I'd put D equals 0, T, which is basically just 0 because VI is 0, plus 0.5 times 0.825 times 6.61 squared, which would give us the distance squared. So if you do that on your calculator, let me do that real quick. 5 times 0.825 times 6.61, I get 2.73 meters to 3 significant figures. If I were to do if I were to take the actual value of like, instead of if I instead took the value of this not rounded, I'll just check what the answer is and see if it's the same. Times 6.61 squared. Oh yes, guys, sorry, I forgot to put in the squared. That's why it's so little. I was wondering. Okay, so it's actually gonna be 18 point. Oh, okay, there we go. That makes more sense. So that's the maximum displacement. Why might this be different? Well, as I explained before, this has to do with other players. So there may be obstacles such as other players that the runner has to dodge. This would make for an indirect path. So his distance is more than the displacement. Direct distance. Okay, I hope that made sense to you guys. And that is pretty much all for this question. Oh, sorry. That's wrong. Okay. Alright, so let me just move this so that you guys can see it properly. There we go. Alright. The softball has a mass. Okay, let's just underline all the important numbers here. So that's the mass, that's the velocity, and it's brought to a stop. That's probably important too. The catcher's arm is relaxed, and the ball on the pad. Okay, cool. So there. That's T. What does the term impulse mean? Okay. So impulse is just the change in momentum. Change in momentum. That is just the tried and tested definition of impulse. There's nothing else to it really. Calculate the average force on the ball on the padded glove on impact. Okay, so they want us to calculate the force. So we have to use the equation P equals Ft. So P is the momentum. So first we have to calculate momentum, which is mv. So P equals mv. That is m, which is 0.180 kgs, times 44.4 meters per second, which is equal to 7.992. 7.992. And remember, the units is kilograms meters per second. And then they ask us to calculate the force. So P equals F over Ft. So F equals P over T. So, that's actually meant to be a capital F, not a lowercase f. Yep, my bad. Okay, so F is equal to P over T, which is 7.992 as we calculated, over the time, which is given 0.51 seconds. So if we do that on the calculator, you get 15.7 newtons to 3 significant figures. Yeah, I think I rounded correctly there. Use physics principles to explain the advantages of catching a ball using a relaxed arm and a padded glove. Okay, so there is basically a question like this every year, so I would recommend you get used to these. And there's always like a set answer pretty much, just depending on the context, it will be different, but I guess I will show you how to write a good, excellent answer to one of these questions. So you want to start by saying, well, they've already told you that momentum is conserved. Okay, so you want to start by giving them the context. So having a relaxed arm and a padded glove. See how I've already linked it to the question. So that will automatically, that's needed for excellence. You need to be able to relate it to the question. Will increase the collision time between the ball and the glove. Okay, so that's your first sentence. You want to talk about increased collision time. Okay? And then you have to say, for the same momentum, and this here is very important. You have to realize that whether he wears the glove or not, the momentum is the same. And that is because the mass and the velocity don't change. The only thing that's changed is him. He's changed. But nothing else has. So for the same momentum, and you can talk about how the mass and velocity don't change in brackets. I've just told you to say it. I'm not going to actually write it. So you're going to say, for the same momentum, the force has decreased. And you have to show this with an equation. So F equals P over T. And over here, let me see if I can draw the arrows. Yeah. So you'd show an arrow downwards and then arrow upwards to show that its increased time means less force. I always do that on the paper so that they know that I can link the equation to what I'm talking about. Okay, and then after that, do you want to talk about, so we've talked about how it's less force, and so then there's your final concluding sentence about, so less force means that the force experienced by the catcher is less, and thus there is less chance of injury. And see how, again, I've talked about the advantage. The advantage is that there's no injury, or less chance of injury. So there, I've fully answered the question, and I didn't even have to write that much, so that's a good thing. Okay, let's move on now. Later in the game, okay, again, I'm gonna underline everything that's important. So there's a 50 kg player, he's moving to the right, and then he collides with a 60 kg player, and he is moving to the left at 0.4 meters per second. Okay, so obviously we don't have the people, we don't have the picture, but I'm just gonna draw some stick figures. Yep, guys, stick figures are the best. Oh, this guy's got really long legs. Okay, and they go at 2 meters per second after the collision. So what physical quantity is assumed to be conserved during the collision? Okay, well that's simple. That's gonna be momentum. This type of question is always momentum. And also it's important to note that this is an inelastic collision, which means that all the energy is not conserved. As you can see, the energy is being transferred into other things when they crash. It's not conserved. So that's why it's momentum, otherwise it would also be energy here. Okay, calculate the initial speed of the 50 kg player. Okay, this is the equation that I always use, and it always works, is this. M1v1 plus M2v2 equals Vf into M1 plus M2. And also over here, you want to say, let me just move this down. You want to say that Pf equals Pi, because remember, momentum is conserved. So the initial momentum is equal to the final momentum. So that's basically what I put there. Okay, so let me just enter that. Okay, so that is my formula, and let me just pop those numbers in. So we have a 50 kg player going at V meters per second, so 50V, plus we have a 60 kg moving at 0.4, so 60 times 0.4 is equal to Vf, which is given 2 meters per second after the collision, and that is to the right. Okay, so right here, it's important to note that I'm gonna make it so that all the people that are moving left are negative. Okay, so in momentum, it's important to note that this is gonna be negative. So when he's moving this way, when he's moving to the left, it's negative, and when he's moving to the right, it's positive. Okay, so that's usually the way people do it. You can also do that right is negative and left is positive, but it's just easier for me because, right is right or whatever. So that is equal to, okay, so actually back here I should make it negative. There you go. 2 times m1 plus m2, so that's 50 plus 60. Okay, so if you do that on the calculator, what's 50 plus 60 times 2? You'll get 220. So 220 here. So you'll get 50V is equal to 220 minus, plus, because remember 60 times negative 0.4 is going to be a negative number. So you want to make it positive when it moves. When this thing moves that way, it's going to become positive. Simple algebra. So it's going to become plus 24 because 60 times 0.4 is 24. Okay, so then you just do 224 divided by 50, which you get 4.48. So let me write that down. 4.48. So 50, yeah, V equals, sorry, it's 244, isn't it? 244, not 24. 44. Yep, there you go. So you get 4.88 meters per second. Sorry, guys. Meters per second. Okay. And then that's to 3 significant figures. So that's the initial velocity of him. But you also want to make sure that you're rounding to the correct number of significant figures. And if you look here, this is the least amount of significant figures given in the question. So you actually want to round it to 1 significant figure. And it looks like this is an excellence question, so that is very important. 5 meters per second to 1 significant figure. Okay. Then you could also write a sentence saying he's going 5 meters per second initially to the right, if you want. Okay. Next question. So again, I'm gonna underline the main things. So it looks like we have a mass, a velocity, and they're going a circular motion, and we also have a distance, a radius. Okay. So what are they asking us? They're asking us to calculate the centripetal force. Okay. So we're going to get Fc equals mv squared over r, which, by the way, is on your formula sheet, so you should be able to find it. So Fc is equal to, and by the way, this looks like an achieved question. 55 times, what's v squared? 7 squared over r, which is 15 meters. Okay, so let me do that on my calculator. 55 times 49 divided by 15. So I get 179.66666. Okay, so then I'll just finally put Fc is equal to, and I want to round it to the correct number of significant figures. Let me actually move this down. Okay. Looks like they're all rounded to 3 significant figures. So I'm going to go 180 newtons to 3 significant figures. Okay. Cool. So that is pretty much that. Okay, it for that question. Add a labeled arrows to show FC. Okay, cool. This is the classic question where they ask you to draw the arrows. Okay, so first thing you want to put an arrow like this to the center. Sorry, and so that is going to be both FC and AC. FC, AC, they're both to the center. That's why it's called centripetal center. And then you have the velocity, which is at a tangent to the circle. I'm getting nice straight lines today. So that's your velocity there. And it's at a tangent, it's 90 degrees to this. You don't need to draw the 90 degrees, I'm just doing it to show you. And that is pretty much it. Okay. So name the force that supplies the centripetal force. Okay, so that is going to be friction. So basically, the friction between the player running and the ground is providing the centripetal force. Because the force has to come from somewhere, in this case it's friction. Okay, so this is a classic question where they ask you, oh, why is it accelerating even though it's a constant speed? Okay, so I'm just going to answer that in real quick terms. This is usually a merit question. So, although the velocity is constant, the direction of the velocity is always changing. This means there must be acceleration. The acceleration acts towards the center of the circle, and the velocity is always 90 degrees from the direction of. I don't know if you really need the last part. I just like to put it in to be safe. But I don't really know if you need it. Okay. And that is all for that question, really. I don't think you need anything else. I mean, you could also talk about there's a force, and hence that's why there's acceleration, but I think that's a bit too much. They really just ask, why is it a constant speed and accelerating, so that's all you need. Okay, the player runs on a muddy, slippery patch. Okay, again, this is one of those classic questions that they always ask, so you need to be ready for these types of questions. But basically, the slippery mud provides little to no friction, so that's always the case. They run into some frictionless zone, and they want you to talk about it, and so let's talk about it. Okay. So when the player hits the muddy zone, it provides little to no friction. This means the centripetal force is no longer present, and thus the player no longer stays in the circular path. Instead, he runs off in the direction of velocity, which is at a tangent to the circle. Okay, and that's pretty much all you guys have to say. Of course, this doesn't look like much, but when you're writing like on paper, it is a lot. So I recommend you kind of just learn this stuff. I mean, it's great to know the principle, but if you can't, then at least know this sort of stuff because this question always comes up. Like it's just so popular there. I think NCEA loves it, and so it's important that you know it. All right, final question. The next batter hits the ball up in the air with an initial velocity. Okay, so again, I'm just gonna highlight the main things. So we have V. Oh, that's terrible, but whatever. We have the degrees, and we have to show that the vertical component is this. Okay, let's do that then. Okay, so if I were to draw a triangle, sorry, it's always easier when you draw out your things. Okay, so you have 22 here, you have 35 here, and then they're asking you the vertical component, so that's this one here. Okay, so then you're just going to use Pythagoras, and it's all pretty simple from there. So sine 35 times 22, and that will indeed give you 12.6 meters per second to 3 significant figures, I'm guessing. Yep, 3 significant figures. And that's all you need for that question. I'm just double checking to make sure that I've done that right. Yes, that is right. Okay, let's move on. Calculate the maximum height. Okay. So the maximum height. So we know that VI. So this is all the vertical component that we're working with right now, okay? So VI, the vertical component, is 12.6. VF is 0 at the maximum height. D is unknown, that's all we're trying to figure out. A is 9.8. And that is all, negative 9.8. And that is all we need for answering this question. So we have the equation VF squared equals VI squared plus 280. Okay. So 0 is equal to VI squared, so 12.6 squared minus 19.6 D. Yes. The reason I got 19.6 is because I did 2 times 9.8 already previously. So we have 159.23 is equal to 19.6 D. So D is equal to 19 is equal to 8.12 meters. And that is to 3 significant figures. Dang, that was quick. Okay. Of course, as soon as I say that, we have a long-ass question. Okay, so the motion of the ball. Okay, they want us to add labeled arrows. And this is kind of weird for NCEA to ask. But basically, all these arrows are pointing downwards. They are all the same size because they're all gravity and they're all meant to be straight. But of course, I can't draw straight. And they're all downwards, okay? And they're all gravity. And that's pretty much it. I guess you could label them like FG or something, but I don't think they really care that much. Okay, and so it doesn't matter where it's at. Really, the whole thing is the only force acting is gravity. And that looks like the first thing we're going to say. So, it wants us to talk about horizontal and vertical. Okay. Vertically, the only force acting is gravity. Horizontally, there is no force acting. Okay. Cool, and that is all you need, I think. I think so, anyway. But I'm sure this is an excellence question altogether. Like, if you get this all right, I'm sure you could get excellence with this. It looks like it, anyway. Acceleration. So, vertical acceleration is 9.8 meters per second due to gravity. Is negative when going up and positive when coming down. And then you could also talk about how it's like against gravity when it's going up, and that's why it's negative, and positive when it's coming down because it's coming down with gravity. But yep. And then horizontal velocity. Horizontal velocity is always constant because there are no forces acting horizontally. Okay. And then okay, so vertical velocity is probably the hardest to talk about, or there's the most to say. So vertical. Okay, so the ball decelerates until it reaches the top where it momentarily stops. Then it accelerates back down, reaches the same initial velocity as before, and then it hits the ground, I guess. I don't think you need to say the part about hitting the ground, I just added it to end the sentence, really. And I think that's it. I could have added a bit more here and there, but I think mostly that's all you need to say. Oh, great, the talks question. Is that the last thing? Yes. Okay, so we'll be done soon. That's great news. Okay, so we have a coach and a substitute player, sorry. This guy and this bench and okay, alright. I see what's going on. They want us to add arrows to show all the forces acting on the bench. I'm guessing that there's no photo here either. Okay, cool. So, because I can't exactly see the pictures here, I'm just gonna draw my own little. Oh, that was terrible. It's a terrible line. Let me try that once more, and if it doesn't work, I give up. Yeah, that was just about as terrible as I could hope for. Okay, I give up. Alright, so I'm just gonna imagine that these players. Okay, so there's a down arrow for these two players. Shoot. Okay, no. This isn't working. Please work. Okay, there's a down arrow, then there's also a down arrow for the bench. And then there's FA, which is a support force. And there's also FB, which is a support force. So there's two support forces in this question. And of course, they want us to do both. Fine. Okay, we can do it. Okay, so TCW is equal to TACW. That's basically saying torques clockwise is equal to torques anti-clockwise. Okay, so we have a bunch of torques to do. I'm gonna make my pivot point support B because it says calculating torques about support B or otherwise, but don't want to take the risk, so let's just be safe with that. Cool. Okay, so basically, if we were to make support B the pivot point, And the way I like to do this is to hold my pin out and just grip the pivot point really tightly, and then bend down in the direction, like bend my pin down. So in this case, this way. So that is clockwise. See, that's clockwise. Because this, if there was only this pivot point and nothing else, then this would fall this way. If this player was sitting here, it would fall this way. And then this is the opposite. It's falling this way. So that's anti-clockwise. And then this is clockwise. And then this is, what is that? That is anti-clockwise. And there, that's probably enough. That's probably enough for now. Okay. Okay. So this is like two different things here. Okay. So I think this is the distance from the coach to the force here. Sorry, guys. This is taking a really long time. I know it. Okay. Let's try hurry this up. So we have the coach. Let's just do clockwise talks first. Sorry. So clockwise talk. So we have if A, which we are trying to figure out, and how far is it from here? If B, it's 0.6. So 0.6 if A is equal to, oh shoot, I'm not writing in the right line. 0.6 if A, is there any other anti-clockwise ones? Yeah, there is. The player, plus the player, the coach, not the player, the coach. Okay, 110 times 9.8. Man, I think I hate talks. You know what, guys? I think I'm just gonna link a video in the description for you guys to watch the talk one, because I can't be bothered with it right now, but I hope the rest of the video helped. Thank you very much for watching. Goodbye. Please subscribe!